Desktop DDR RAM. This is the standard memory stick you will find inside almost all modern desktop computers. It features a long, rectangular circuit board lined with memory chips and a single notch on the bottom pin connector that prevents it from being inserted into the wrong slot generation. Over the decades, it has evolved from the original DDR specification through to modern iterations like DDR4 and DDR5, with each step significantly increasing data transfer speeds while lowering power consumption. It matters because it is the backbone of traditional personal computing, giving the processor quick access to open applications and heavy tasks like gaming or media editing.
Laptop SO-DIMM RAM. This version shrinks the standard desktop memory module into a much smaller footprint, roughly half the length of a traditional stick. Because space inside laptops, mini PCs, and small form factor devices is incredibly limited, these modules allow manufacturers to deliver the same essential memory capabilities without bloating the device's physical size. While they operate on the exact same technological generations as desktop memory, their smaller pin layout means they are completely incompatible with desktop slots. They are crucial for users who want the flexibility to upgrade or replace their portable device's memory over time without needing to buy an entirely new machine.
LPDDR RAM. This memory is specifically engineered for ultra-thin laptops, tablets, and smartphones, where power efficiency is just as critical as space saving. The letters stand for Low Power Double Data Rate, and unlike standard modules, these chips are almost always soldered directly onto the device's main circuit board, rather than arriving on a removable stick. By removing the traditional slot mechanism, devices can be built incredibly thin, and the memory consumes far less battery power when the device is idling or asleep. It represents a major shift toward unupgradable, highly integrated hardware designs that prioritize all-day battery life above everything else. ECC RAM. This specialized memory includes an extra memory chip on the board designed to detect and automatically correct internal data corruption. In standard consumer hardware, microscopic electrical interference or cosmic rays can occasionally flip a single bit of data from a 1 to a 0, causing a sudden application crash or a blue screen. For home computers, this is a minor annoyance, but for high-stakes environments like financial servers, scientific databases, and cloud computing centers, a single error can be catastrophic. Error-correcting code memory prevents these system crashes by constantly verifying data integrity on the fly, though it requires specialized server-grade processors and motherboards to actually run.
RDIMM RAM. This type is also known as registered or buffered memory, and it is designed exclusively for high-performance enterprise servers and heavy-duty workstations. As a server demands massive amounts of memory, the sheer number of individual chips places a heavy electrical load on the CPU's memory controller, which can degrade the system's stability. Registered modules solve this by placing an onboard hardware register directly between the memory chips and the system processor, acting as a traffic controller that buffers the electrical signals. This small delay slightly increases latency, but it allows a single system to reliably run dozens of memory sticks simultaneously without overloading the hardware.
VRAM. This memory is completely isolated from the main system and lives directly on a dedicated graphics card. While standard computer memory focuses on running the operating system and general applications, video random access memory is custom-built to handle massive amounts of visual data, texture maps, and complex 3D geometry simultaneously. It uses specialized high-bandwidth architectures like GDDR6 or high-bandwidth memory to feed data to the graphics processor at speeds standard system memory cannot match. This separation ensures that rendering a high-resolution video or running a visually demanding application never competes for bandwidth with the rest of your computer's background tasks.